It is easy to think that quantum mechanics is just a theory about small particles, nothing more. But what if I told you that it could actually suggest that you will never truly die? Quantum immortality. Quantum theory whispers that the nature of existence transcends the logical frameworks we are accustomed to. As Einstein described it with the phrase, "God does not play dice," at the core of the universe lies uncertainty, potential, and wonder. In the quantum world, nothing is certain. Particles do not remain in a specific position or at a specific speed. They are everywhere and nowhere. They exist within multiple possibilities at the same time. This perspective tells us that we must rethink not only the subatomic world but also our consciousness itself. Because quantum mechanics actually speaks of a sea of possibilities, superpositions. An electron, for example, is not just in an up or down spin state. It exists in both states at the same time. However, when we observe it, when we make contact with it through consciousness, it appears to make a choice. This strange yet profound behavior is most clearly demonstrated in the double-slit experiment. If you send a single electron toward a wall with two slits, you will see an interference pattern on the screen behind it, as if the electron had passed through both slits at once, existing in two places simultaneously. Here, the electron is not a particle but a wave, a form of energy. However, when an observer intervenes and attempts to track its path, the magic is broken. The interference pattern disappears, leaving only two faint traces. The electron ceases to be a wave and behaves like a particle. This simple experiment reveals a profound truth. Reality is far more flexible and intertwined with consciousness than we imagine. And if you're confused, you're not alone. As Richard Feynman once said, "I think I can safely say that nobody understands quantum mechanics. But perhaps the issue is less about understanding and more about feeling, listening to our inner intuition, and expanding our perception of reality." The quantum world whispers to us, without observation there is no result. In the infinity of possibilities, existence flows like a wave. This wave, or sea of possibilities, is called the wave function. It was defined by Schrödinger. The question is, why and how does this energy state, this potential existence, suddenly transform into a single concrete state, into classical reality? Modern physics has answered this question for years with the Copenhagen interpretation. Everything is in superposition until observed with observation. It collapses into a single reality. This collapse occurs according to a probability law known as the Born rule. And yes, this theory has been experimentally verified in an extraordinary manner. However, it still does not answer the question, what is actually happening, and what exactly causes this collapse? Many physicists argue that the collapse has nothing to do with human consciousness. They say that observation does not require a human being. Even a photon is sufficient. But that photon is also quantum and could be in a state of superposition itself. So where does this chain break? This leads us to another truth. All entities, all particles, even systems are interconnected. This connection is called quantum entanglement. And this principle operates not only in the physical world but also in the realm of consciousness. Quantum computers, teleportation, and cryptography are based on this principle. But what if entanglement isn't just between particles? What if we, as observers, are also part of this superposition chain? And now the question arises, if quantum effects are valid at all levels of existence, why don't we experience any superposition in our daily lives? Why do we experience this magical flow of possibilities as a single reality? This mystery becomes even more apparent with the thought experiment known as Schrödinger's cat. A cat placed in a box, alongside a poison mechanism that will determine the quantum outcome. As long as the electron's spin state is uncertain, the poison remains unbroken spiri, so the cat exists both dead and alive. But when we open the box, a reality is determined. But according to what? The Copenhagen interpretation attempts to explain this situation, but it contains many contradictions. Because then why are we the observers, classical entities, while the electron remains quantum? Isn't every part of the universe governed by the same laws? And so the question is, what is reality? And how should we understand our place within it? I will explain this to you shortly. By watching the video until the end, we will uncover the secret behind quantum immortality together. And if you are also curious about this information, Write 777 in the comments to send a powerful message to the universe. If you're ready, let's begin. In 1957, Hugh Everett, a young student at Princeton, offered a radical alternative to the quantum interpretation that had been accepted until then. What he proposed was not complicated, but rather quite simple. The wave function never collapses. No possibility disappears. No reality is erased. Each one simply diverges from the others and continues on its own path. What we call collapse is simply the silent separation of branches that our eyes cannot see. Every possibility that could arise in a quantum measurement creates its own reality. Each one is like a parallel path that does not touch or interfere with the others. Everett's interpretation of multiple universes was ignored by the physics community for many years. Perhaps the idea was beyond the limits of the mind. But as time passed, intuition began to take the place of thought. In the last decade, thanks to figures like Sean Carroll, David Deutsch, and Max Tegmark, this approach has regained seriousness. Because the issue is no longer just about explaining things with equations, it is also about trying to hear what the universe is saying. What Everett did was to approach Schrödinger's equation with complete honesty. There was no collapse in that equation, and if the equation is correct, the result is clear. The electron, the box, the cat, you, me, we are all, along with the entire universe, in a massive and indivisible wave. This is called the universal wave function. From this perspective, instead of a discontinuity like collapse, the name for what brings forth the classical image of the macroscopic world is decoherence. That is, the vibrations drifting apart and turning into their own independent melodies. And here an important question arises. If the entire universe is in a superposition, why don't these branches interfere with each other? Why don't they interfere like in the double-slit experiment? The answer lies in phase coherence. In simple systems, quantum waves can remain synchronized and thus interfere with each other. But as the system becomes more complex, interactions between particles disrupt their phases, synchronization breaks down, and realities cleanly separate from one another. We call this separation process decoherence. It is a silent, gentle but irreversible branching, and from this point on, the universes can no longer influence, hear, or feel each other. This branching is not an instantaneous break. It is a separation that develops over time, occurring unnoticed. As decoherence spreads, the vibrations of possibilities grow increasingly distant from one another. There is no longer any cause and effect relationship between them. So no, you cannot gather with your versions from other universes to form the Rickler Council. And yes, this may disappoint you a bit, but it also demonstrates the immense creative power of the universe. Branching has been going on since the Big Bang. Every choice, every interaction, every coincidence creates a new branch in the universe. And this process is not only physical, it is also mental. In fact, there is now an app that allows you to make decisions based on a quantum measurement conducted in Switzerland. This video was published at 2 p.m. in this branch, but in another branch it was 1 p.m. Both happened. Both are real. And if this idea seems strange to you, you're not alone. Theoretical physicist Bryce DeWitt, when he visited Everett, said he found his ideas mathematically very compelling, but couldn't quite feel like a constantly dividing entity. Everett simply asked a question: do you feel the sun rotating around you at 30 kilometers per second? There was no answer, because not feeling it doesn't mean it doesn't exist. Reality is sometimes imperceptible, but it is still there. And sometimes when you think you are breathing, you may just be experiencing a possibility. In the extension of this thought, the idea of multiple universes is not just a theory, it is a mirror of yourself, your consciousness, and how you perceive death. In the world of physics, Everett's approach began to gain increasing acceptance due to its consistent adherence to Schrödinger's equation. But hidden within this perspective was a strange and frightening consequence that quietly shone through. As detailed in Max Tegmark's book, Our Mathematical Universe, this idea can be likened to a kind of quantum Russian roulette. Consider the scenario. Every second, a measurement is made. A particle is in a superposition of two states, up spin or down spin. The measurement is made. If the spin is down, a bullet silently finds you so fast that you don't even notice it. If it's up, only an audible click is heard. A pulse oscillating between death and silence repeats every second. And this measurement continues to drip into infinity. According to Everett's theory, two universes are born every second. In one, you die. In the other, you live. But your stream of consciousness, the I you call yourself, can only continue in one of them, because you cannot experience death. Consciousness cannot perceive death, so you always experience the surviving version. And in this endless cycle you constantly hear the click sound. 1, 2, 5, 40. Each time you are in the same room as death, but only the other you knocks on the door, not you. According to the Copenhagen interpretation, your chance of survival after 40 clicks is 1 in a trillion. But according to the multiverse theory, 100%. Because each time one you continues to live, and since it is that you who experiences it, there is no death for you. Therefore, theoretically, if you try enough times you could even prove that Everett was right as the lone surviving consciousness. But here's the strange part. This proof only applies to you. All the other versions, the people in those other universes, only see you as dead. And in those worlds, only one painful question remains. Why did you do such a thing? Everett never spoke of this experiment, but according to his biography, he deeply believed that his ideas implied immortality. In his view, consciousness was compelled to follow the path where death did not exist at every branching point, and this was an endless stream of awareness. Unfortunately, things did not go that way for him in our branch of the universe. His theories were largely rejected. He could not find a place in academia. He withdrew into himself. He drank heavily, smoked heavily, and he died of a heart attack at the age of 51. Perhaps another branch of his consciousness is still alive, still thinking, still telling stories. But in this branch, his story ended like this. Max Tegmark clearly states that this experiment is merely a thought experiment and should never be attempted at home or in real life. I also make the same warning explicitly. Wanting to explore the boundaries of reality is one thing, sacrificing them is another. Nevertheless, the idea persists, because humans are the only beings capable of imagining both death and eternity at the same time. And behind this experiment lie these three fundamental conditions. Randomness must truly be quantum. Death must occur before the threshold of perception, and yes, it must truly kill, not just injure. If these three conditions are met, according to the theory, consciousness never deviates from the line of life. Each time, a click. Each time, another breath. And finally, another reality whispering quietly, "You are still here." In a lecture he gave in 2001, philosopher David Lewis used quantum Russian roulette as a starting point to present a broader understanding of immortality. According to him, if the entire universe is ultimately governed by quantum events, then what we call death is merely the result of these random quantum fluctuations. And this means that all causes of death already naturally satisfy at least two of the conditions Tegmark set for his experiment. Lewis's suggestion was strange and unsettling. Suppose a car is about to hit you. At the level of quantum probabilities, there is a chance that the car will pass through your body without harming you. That is, tunnel through you. It's close to impossible, but not zero. And according to the multiverse interpretation, there must be a branch where this possibility occurs. So, one you always becomes the version that survives. Over time, this branch of consciousness, which always escapes death, extends into infinity. If Lewis is right, then we will all one day witness our own immortality. Perhaps we will miraculously survive accidents. Perhaps we will overcome illnesses. Perhaps we will remain while everyone around us passes away. Everything will change before our eyes, but we somehow will continue to exist. However, Max Tegmark is skeptical of Lewis's interpretation of immortality, because according to Tegmark, most death is not sudden. It is a slow, perceptible process of dissolution, like aging, like losing one's mental health, like the body slowly withering away. And these processes are directly experienced by consciousness. In other words, they are inevitably felt, and if you can feel something, it's harder to escape it. But Lewis had anticipated this as well, and unfortunately, his answer was a rather bleak prediction. He says that at a certain point, it's no longer necessary to stay good. In other words, if immortality is solely about staying alive, this survival will continue no matter the cost. You can lose your eyesight, your limbs, your memory, your health, your loved ones, but your consciousness, at least in some form, always remains. Even if surviving each danger seems like a miracle, each time you emerge a little more diminished, a little more alone, a little more forgotten. Lewis writes this clearly: one who survives deadly dangers repeatedly will also suffer repeated harm. Over time, the body fades, the mind fades, the heart grows lonely, and such immortality eventually becomes nothing but endless torment. Eternal life is sometimes nothing but eternal loss. Is this our fate? Will consciousness truly continue endlessly as a lonely, worn-out and exhausted entity? Or is this merely another dark dream of another branch of the universe? Since quantum immortality is so personal, a good question to ask is whether our own experiences of the world are consistent with its predictions. Returning to Tegmark's second criterion, which argues that you must die or become unconscious, it should be noted that equating these two states is itself a bold assumption. Nevertheless, the reasoning is logical. In both cases, death and unconsciousness, there is no awareness. Nothingness is closed to an observing entity. Physicist Anthony Aguirre focuses on this point in particular. In his book Cosmological Koans, he raises the following question: what about states in which we are not conscious but still alive, when under anesthesia or in deep sleep? In those temporary realms of nothingness, does consciousness truly disappear, or does it merely withdraw inward? We can question this as follows. If quantum immortality is true, wouldn't you always have to live in the branch where you are awake? Because only that branch can offer you experience. You cannot perceive the nothingness of the branches where you sleep. But then we realize that there are also dreams. And dreams are like a bridge between unconsciousness and consciousness. Moreover, sleep is not an infinite state. After 8 hours there is a you who wakes up again in every branch. Therefore, temporary loss of awareness does not mean absolute loss of existence. Thus, quantum immortality does not fall into contradiction here either. At this point, another intellectual tool comes into play: the anthropic principle and its related principle of mediocrity. This approach states, if we are truly immortal and physical decay is inevitable over time, then we should spend most of our existence in a weakened, aged and forgotten state. The fact that you are watching this video in a young, healthy and vibrant state, that you are in this version right now, would actually be a statistically very low probability. It would be more likely for you to be an immortal but exhausted version, like the Struldbrugs. But you are not. Isn't this a contradiction? This seems like a strong counter-argument. If what you're experiencing is quantum immortality, why are you here now in this consciousness, in this youth, rather than in the longest-lasting, most ordinary, most degraded version? But this objection also fails to provide a definitive answer, because this line of questioning, just like in the doomsday argument or the Boltzmann brain scenarios, always gets stuck on the same ground: the reference class problem. Who are you right now? Which self do you identify with? Which version do you consider average? Perhaps the state you are in right now, this form of consciousness, is the most ordinary one within your own reference frame. And then the contradiction disappears again. All these mental loops do not lead us anywhere, but they do show us one thing: none of them can definitively disprove quantum immortality. Because the issue is not just about physics, but about consciousness. And consciousness sometimes leaves logic behind. But if we return to Lewis, there is still a questionable foundation in his assumption. Perhaps what this theory is built upon is the shadow of a single assumption about how the universe works, and perhaps it is time to question it. At the heart of David Lewis's defense of quantum immortality lies an idea he calls the corrected density rule. And this idea reveals perhaps the deepest tension surrounding multiverse interpretations, which you really live. Imagine a quantum-triggered fatal event occurs. There are 4 possible outcomes. In 3 of them, you die. In 1, you survive. According to the Copenhagen interpretation, we assign a 25% probability to each possibility using the Born rule. And only one of these 4 paths comes to pass. But in Everett's world, things don't work that way. All outcomes occur simultaneously, each with 100% probability, but in different branches. The problem here is clear: if everything is happening, then this theory cannot make predictions. That's why Everettians assign an existence density to each universe branch. In this scenario, each outcome has only a 25% existence intensity. Consciousness can only experience one path. And so the result that you have a 75% chance of dying in that deadly scenario emerges. Yet if you're still alive, it means you're continuing to walk in a branch with only a 25% existence density. Here Lewis makes an unexpected move. He eliminates all branches that result in death. Why? Because according to him, death is nothingness. You cannot experience nothingness. And you cannot count something you cannot experience as lived experience. Therefore, he looks only at the branches you have lived and creates a new balance. He calls this rescaling process, where the remaining probabilities are normalized by excluding the death branches, the corrected density rule. And this is the foundation of Lewis's understanding of quantum immortality. But here too, a conceptual conflict arises. Many philosophers and physicists view this approach as a clever illusion. For example, David Papineau asks, why would Everettianists change this rule only in cases of death? If the same density rule can be applied everywhere, why should it work differently here? Similarly, David Deutsch, one of the leading advocates of multiple universes, also opposes this idea. According to him, this is a hypothetical preference that does not naturally follow from quantum theory, but was added later. And this preference says that the conscious decision-maker should not look at the branches where they no longer exist. Deutsch says, in my opinion, this assumption is wrong. In short, every time the universe splits, there is no guarantee that you will always survive. The you that maintains conscious existence is a possibility, but at the same time, you are also a wave that disappears. In every choice, there is existence, but in every collapse, there is silence. And this brings us back to that ancient question, what is experience? Who are you? And which you truly survives? At this point, we begin to ask the question not only with quantum mathematics, but also with human intuition. If consciousness can only continue in the arms that continue to live, is there really such a thing as death? David Lewis's idea is one of the cornerstones here. Death cannot be experienced. According to him, all branches of the universe that result in death are empty from the perspective of consciousness, because there is no you to experience them. But many thinkers object to this idea, because even the idea of not existing resonates within us as a mental reality. And for the human mind, this may be more shocking than real death. Let's think about it. If death doesn't really exist, why is there fear? Sometimes, to explore this question, we need not physical but more metaphorical examples. For instance, imagine that famous transporter from Star Trek. It disassembles you in one place and reassembles you in another. A moment of non-existence, and then existence again. And yet the you that reappears still feels like you. But what if there's a mistake? What if it splits you into two? Two consciousnesses awaken simultaneously, remembering the same past, calling out the same name, I. So, which one is the real you? This is where Lewis's idea comes into play. Consciousness can only continue in one branch, because two different conscious experiences cannot be experienced at the same time. But then the question arises, what will happen to the other version? If one continues to live, what does the other's disappearance signify? Even if its consciousness is gone, its potential existed. And we humans feel the loss of potential as if it were death, because death is not merely an end, it is a sense of loss, a diminishment. And perhaps despite the mathematical elegance inherent in existence, consciousness can never accept this indifferently. Sean Carroll's classic analogy illuminates this point. If someone stabs you in the back, you might feel nothing, but knowing it now disturbs you, because death is not experienced only in that moment. It builds up inside you like a wave of fear that comes from before. This is where Lewis's idea that consciousness continues indefinitely, and therefore death is not final, clashes with such intuitive fears. While physics says that consciousness is a continuous wave, the human heart still fears the final curtain. And perhaps the most unsettling thing is this. In each division, only one you survives, but the other yous disappear. And these disappearances are so numerous that the surviving you becomes almost a statistical miracle, because the universe has split countless times since the Big Bang. Countless possibilities, countless variations, and you are still alive in one of these infinite branches. This is where the real question arises. Why are you still here? How did you, among billions of fragments, become the you reading these very lines? Perhaps that is why reality cannot be explained by probabilities alone, because you are still here. Among all those possibilities, as a consciousness that has emerged from billions of fractures, you are still reading, you are still here. And perhaps the question is your consciousness merely the result of probabilities, or is it a reality large enough to encompass all possibilities? And so we finally come to it. Everything we've talked about up to this point, wave functions, parallel universes, ideas of immortality, has actually revolved around a single question: who are you? This strange concept has more to do with the nature of the mind than with quantum reality, because even after all these branches, probabilities, and superpositions, the real issue remains: what does you refer to? Self, identity, consciousness. Which one is really you? This is perhaps one of the most difficult questions humanity has been pursuing for thousands of years, and it remains an unsolved mystery, sometimes a philosophical paradox, sometimes a scientific unknown, sometimes an inner silence. Physicist Brian Greene from Columbia University thinks every copy is you. That is, there are different yous, each with their own stream of consciousness, and each can say I from their own perspective. True selfhood, perhaps, is the sum of them all. Like the branches of a river, streams of consciousness that diverge into separate paths, but originate from the same source. On the other hand, Lev Vaidman offers a simpler, more down-to-earth perspective. There may be many versions of you in different worlds, but the entity we call I is the one thinking these lines right now. The other yous may be identical, but they diverged in different timelines with different outcomes, and all of them originated from the current you. But each now carries a separate sense of self. However, philosopher David Wallace takes this discussion even further. According to him, if selfhood can only be defined in one branch, and these branches are completely isolated from one another, perhaps there was never such a thing as a single you to begin with, and the multiverse, rather than multiplying our identities, is dissolving them. What we call you might be a fluctuating illusion. Just as in the black hole information paradox, two major structures are colliding here: quantum physics and selfhood, and this collision gives rise to a contradiction. It's as if there is a flaw not in the nature of the universe, but in our own internal definitions. It's as if we are asking the wrong question. Instead of who am I, perhaps we should be asking what am I? Cosmologist Anthony Aguirre's words succinctly summarize this contradiction. All these conflicting ideas, the nature of death, multiple selves, quantum splits, may stem from a fundamental misconception, because what we call I is not a fixed identity. It is a wave that is reborn every moment, changing shape with every observation. Perhaps you are a temporary reflection born within an experience, a fold of consciousness that takes on a different form with every choice, and you have never truly been one. So the question is no longer scientific. It becomes a personal and internal question. Who is observing this universe? Which I makes you who you are? And when that I stops looking, are you still there? On October 27, 1962, humanity came to the darkest threshold in its history. In the midst of the Cuban Missile Crisis, a Soviet submarine was surrounded by American destroyers. The Americans dropped signal flares into the water, but the Soviet captain thought it was a real attack and gave the order to fire a nuclear warhead in retaliation. Everyone except one person agreed. Vasily Arkhipov. He quietly said, no, and the world was spared from destruction. That day, World War III did not happen, and we are here. Perhaps only because of that decision. But if multiverses are real, perhaps that war happened somewhere else, and we could not live in that branch. Because perhaps consciousness flows only along the paths it can continue, and all of history is only the branches where you could be born. The rest, silence. Quantum immortality may seem strange. It's easy to reject, but perhaps this idea is not an answer. It's a mirror. Because as we circle around the question, who am I? The universe quietly whispers something else. Infinity is not outside, it is inside. Lewis's design for immortality may be dark. Yes, a worn-out copy of endless existence. But perhaps the point is not to live forever. It's about realizing the infinity of every moment. And the beautiful thing is, if the multiverse is real, in another branch, Hugh Everett is still alive. He's won the Nobel Prize and is explaining quantum mechanics to his grandchildren. He's smiling slightly as he plays chess against David Lewis. Perhaps in one of these universes, your dreams are coming true. The people you love live longer. The pains of the past are resolved in other ways. Yes, we cannot enter these worlds, but their existence proves something to us. These dreams are possible. Somewhere in reality, they are truly happening. And maybe that is enough to hope, to heal, to build. Because if the universe is divided into countless branches, then you are standing at the door of infinite potential. So live with awareness, choose with compassion, and with every blink of an eye, leave a mark on the universe. Until one day, the answer to the question, "Who am I?" rises from within you like a whisper. I am possibility itself. If this video resonated with you in some way, subscribe, like, and share your thoughts in the comments. See you on the next timeline.